I'm John Kline from the Los Alamos National Lab, and I am the Inertial Confinement Fusion Program Manager. I love working at the national labs. Most of what we do is big science. Problems like inertial confinement fusion. Getting to a condition where we can actually study a burning plasma is unique. It's found in a lot of astrophysics systems. It's a very difficult thing to do in the laboratory. Modeling ICF implosions is a really big challenge. It takes these large codes that are multi-physics codes. When you add everything together, it doesn't always give you the real physical answer. These tools become a guide. They're meant to give you some insight into what happens when you make certain changes to the target design. These codes run on large clusters of computers with many thousands of nodes, and these computations can sometimes take months to complete to do a full 3D implosion. In 10 years, the computers will be even faster. And multiscale computing will let us use different computing tools where a code is designed to really capture a certain piece of physics really well. We can run it separate from the big code, use its information and feed it into an overarching code, which allows us to do better computations so we can be even more predictive about what we would get out of these things and how we could use these systems to march towards getting the conditions we would like to have for, say, inertial confinement fusion. We were actually quite far away in some of the early experiments. We went to where the code said, this is going to work. And of course, it didn't work as nicely as they said. And the evolution became much more consistent and predictable. And from those experiments, we've made a lot of progress. The improvement on the symmetry and how well the yields are going up and some of the pressures we're able to achieve is up by enormous factors. That's just really exciting, being on that forefront. Things like inertial confinement fusion or high energy density physics, that work really takes an integrated community to solve problems. I like the interpersonal interactions because all the people have different skills and we need everybody to be a part of the team to be successful. You're always learning something a little bit about other fields or how they interact. That diversity in one field makes plasma physics a really exciting field to be part of.